Hello again. One of the really neat things in Ruby that we need to talk about are loops and blocks. Uh, you know how to do looping in Java. You have your while loop, you've got your for loop, and then really with that for loop, just about everything is done. Um, Ruby's got a while, and it has a for in, which you should check out. I'm not going to talk about it. It's not hard to use. Um, but what you see all over in Ruby are these other sorts of looping mechanisms that, on first glance, they either look, "Ah, that's easy," or they're like, what in the world is going on here? Um, so those are what I want to talk about today. I want to give you some examples of them. Then I want to explain what's really going on in them so that you can understand them. All right. So let's take an example. So let's say we go and we make ourselves an array alpha, and we initialize it with the elements 1, 2, and 3. Now in Ruby, we can iterate through these elements and do something with them as follows. So in other words, basically this is like doing a for each of these elements. So we can do alpha.each, and then we do, and we do this vertical line. It's not a slash, vertical line, x. Or we can put any variable name in here that we want. Let's do this code, puts x, and then end. All right, some things to note that basically what we're saying here, this code is for each element x in alpha do this. The stuff that's in here and this stuff here from the end to the do, this is kind of what well, the whole thing ends up basically this thing here in red is really what we're notion of. This is a block, not a black, a block. A block. Okay, so from the do to the end, that's a block. But basically it's for each, this is the way to read this is, for each element in x, take that element, the next one, stick it in x, and do what's in between here up until the end, okay? And you can have variables from within the program, access them inside of here as you would expect. It's just behaves, it kind of behaves like you would expect, and this is really syntactically really nice. It looks a little mysterious, but it's nice. And what is this? In this code, it outputs, and we do a little box here. It outputs quite easily 1, 2, 3. The puts takes the x. First element is a 1, and so it outputs the 1 on a line. Then it outputs the 2 on a line and a 3 on the line. And then we're done, and the program continues running. All right. Now, there's another way you can write this. So we can take our alpha and our array, and we want to put it all on one line, and sometimes it's convenient to do that. We do alpha each, and now we use curly braces. This is why we don't use curly braces elsewhere in Ruby, like the way we use them all over the place in Java. And x, and then we can put our statement, puts x in here, and we match that with the curly braces. And so these guys, these are, these are basically the equivalent of the do, and the end, okay? And this is to create a block. It's not the same notion as a code block, which is with curly braces. in Java. Blocks have a special meaning and utility that we'll show you, but so you can do these curly braces. And so again, this basically says, for each element in alpha, put that into X and then do the code that follows it. So that's the way, you're going to see this all over the place in Ruby. You definitely want to know it. And by the way, there's all sorts of cool stuff that you can do in Ruby. There's a bunch of things. I'll just show you one of them here. You could say, let's say you've got some variable that you've computed. Right now, we'll just stick like 3 and count. But you can actually take count, and you can do dot times. Now, not as in multiply, but as in the number of times I would like to do something. And then do your do, and then your puts, and then let's say hi. It's always something nice. And so it works the same way. Basically, for count times, do the following code. And so this outputs, again, as you would expect. If I draw it as the output here, it goes hi, hi, hi. Nice. Now, I think the big thing is like, how does this work? Is this just syntax that you're supposed to learn? No, it's not just syntax. There is syntax to learn, the do and the end and those curly braces. And when we want to have something that we pass in, we've got those vertical lines and the variable name. So you can learn it as syntax if you want and just memorize that that's the way it goes. But it'd be nice to understand what's really going on here, so that potentially you can better understand, but also maybe leverage it in some useful way in the future, although you may never have to. So for that, let's learn about blocks. Okay. So to learn about blocks, what is a block? Well, blocks basically, I want to get it right here. Jeez, my apologies. Sometimes this is why my notes are not your notes. Yep. All right. So basically, you'll see this in the Engineering Software as a Service book, textbook. Blocks are essentially what we would call, in computer science terms, anonymous lambda expressions with closure. It's like, whoa, closure. There's an R in there, closure. So once you take some courses in theoretical computer science, you'll go, oh yes, anonymous lambda expressions with closure. But what good does that do you? It doesn't do you any good at all to know that. So let's start over. Now another language that you have learned is R. So in R, one of the concepts here that's really neat is that when you learn a new language, you often learn new things, new ways of expressing and solving problems. And they get repeated in other programming languages. There's only so many programming language ideas out there. And in R, you actually perhaps got introduced to some new ideas, although you may not have realized it. And those ideas exist as well in Ruby and in other languages like Python. And they might exist nowadays in Java, but certainly not the way we don't teach you about lambda expressions in Java if they do exist. I actually haven't checked, but when I knew Java, it did not have lambda expressions. All right, so you can do this in R. And this is kind of neat. So we do centimeter underscore to inches. So here, let's say I want to write myself a function. So I can assign to it, and I write function, and I'll function will take in one argument, and I can do centimeter divide by 2.54. All right. So by the way, already we see some like really cool similarities to Ruby here with in functions for R, the last thing you do becomes what it returns as a value. We don't actually have to say return, just like we don't have to say return in Ruby if the last thing that we have that's computed and returned by a statement is what we want the function to return. Personally, I feel after decades of programming in C, C++, Java, C#, other languages, I feel greatly comforted by the return statement. It's really clear to me that when someone says return something, that's what we're returning. There's no doubt at all in my mind that that's what's being returned. So I actually like to write those extra letters, return, and use that word, but nevertheless. So this will take in, when we pass in some value, it'll divide it by 2.54. So assuming someone passes us the centimeters, we'll get back converted the amount of inches. Now, and so this is the way we set up, and we can call this. So for example, now I can call this as a function, centimeter to inches. And if I pass in 2.54, this will return the value of 1. Okay, so yeah, if I had 2.54 centimeters, it's equal to 1 inch. Great. And you're like, that. Thanks, Mark. I knew that. Okay, now let's go one step further. All right. I can do this, though, which is kind of neat. I could take Mark, and I could assign to it centimeter to inches. You're like, and then I could go, just so you know, I could go Mark and pass in to it, do a method call on it, a function call, 2.54, and it's going to return 1 as its value. Now, what is really going on here? Well, what's going on here is pretty cool, which is centimeter to inches is a variable. It's just a variable. I could, if I wanted to, I could set it centimeters to inches to 10, and then it would be a variable holding the value 10. I could put a vector or anything I want into centimeters to inches. But at the moment, I put in it a function. So there's actually a notion in R that functions are something that we can pass around, just like integers, doubles, vectors, and other things in the language. We call these this is a first-class data type in that we can actually hold it in a variable and pass it around. And so the function itself is something that's an entity that can be passed around in R. We can't actually really do this in Ruby, but we have a more restricted sense of things in Ruby, but we'll get there in a moment. So what happens here is all I'm doing is copying the function into Mark as well. And then Mark, when I call it, it calls this function here and runs it. Okay, this is cool stuff. All right, now, so the thing is that's happening is this here. This is really, this creates an anonymous function. All right, so we can, in R, call this method function, whatever, and it creates a function, and it has no name. We store it in a variable that when we use the call syntax on it, then says, well, I need to call it as if it's a function, and in fact, it turns out that inside that variable there is a function, and so everything works as we expected. But unlike Java and Ruby and most languages where functions have a name and they're just there. We access them via one name. Here, they can float around without any name. We can pass them around. We could have a vector of functions, all right? They are a data type in R, all right? Now, an anonymous function in Ruby, this is what we're going to call is a block. And I think it's called a block probably because it's used like a block of code, like we saw in those examples where we're iterating through things. And because it's not truly, in Ruby, we don't truly have these first-class functions that we pass around. And so it would have been wrong for them to have called them that. So they had to give them another name. But they are essentially like them in understanding how they work. So let's dig into that more now. All right. I did actually want to have more of an example here about passing around functions. And I think it's worth actually showing it to you. So let's go ahead and do that. I could go ahead and I could make a function. This is in R. We're still in R. Inches to feet. And this function, we say inches. And to convert inches to feet, we divide by 12.0. Okay. All right, simple enough. Now we could write a method just for the fun of it. For example purposes, we could go g of f, and we say this is a function, and we could pass in g f x, and then we could go g f of x. So we're defining a function where we have g and f, which we're passing in. These are functions, because we're going to see, you can see we're going to call g and we're going to call f, and x is some data. So this is really interesting. Will this work in R? And the answer is yes, it does. So you could then call g of f, and I could pass in inches to feet. I could pass in centimeter to inches, and then I could pass in 2.54 times 12. And what's going to happen? Well, this is G, is inches to feet. Centimeters to inches is F. So centimeter to inches, when we've got 2 times 54 times 12, we divide it by 2.54, we get back 12. Now, when we call inches to feet and we pass in 12, we'll divide that by 12. And so, you know, this thing all returns, again, 1. You know? So this is just an example that in R, we can pass around functions. We can have functions as arguments to functions. Woo! And you get to actually see this. This happens quite a bit in R. And it's a really powerful technique that R has, that you can actually pass in to a function another function. And that function then uses and applies that function to the data in a certain way for you. It's an extremely handy thing. All right. So what I had meant to do is then tell you, hey, in R, again, these anonymous function things are called blocks. All right, now continuing on. Let's see this in sort of its low-level raw form in Ruby. So back to Ruby land. So make a little note here so that you know that we are back in Ruby and away from R. So let's go ahead and define a method. Def my method. And we put an ampersand and then no space and then my block. And again, this could be any variable name This could be any name that's appropriate for a method, all right. And then in this method, we're going to say puts. To help us keep track, we're going to say we're in the method. And then we're going to do my block dot call. So it's basically saying, this is a special Ruby notation to say, we want to call this block call like we want to call a function. Okay, so it's really, I want to call this thing as if it is a function. Which again, it's going to be like, this is special syntax to say, it's like in R, oh, we're going to actually be passing in a function. Now, again, we can't just pass in any function in Ruby. We can only pass in blocks. So what this is really saying is, when you have this ampersand here, is my block is going to hold a block, which is like an anonymous function, but it is not a function in Ruby. So then we can call it. That's a special way that we can call it. And let's just go ahead and do this twice, just to show you that it's not just a one-time thing. And then when we can put backend method. Now you'll understand why I'm saying this in a moment. And then we'll say end here. And so this is the end of the method. Now, what I can do is I can call my method. I don't need any of the parentheses, but if I wanted to, I could put 2 parentheses here. But for the purposes, also this is where poetry mode makes things look nicer. I can then go ahead and say do, and let's say I do put hello, and then end. Now remember that we've already said that a do and all of this forms a block, okay? And so what we're really doing here is this block is being sent to my method. So my block ends up referring to this code in between the do and the end. It basically says, when you tell me that you want to call it, do this code here. All right. And so what happens when this runs, so this just defines my method, and then we're going to call my method and pass this block to it. And so we go and we happen to get then quite nicely output. That's going to look, first it goes here and it says, oh, yep, in method. Then we're going to call my block, which says, oh, this is the code in the block. Let's do it. Puts hello, so we get a hello. We call it again, so we get another hello. And then we're back here. We're back in the method because this is kind of like leaving to go do another function, and then we're back. All right, and so now we're back in the method. Or we're at the end of it, whatever you want to say. And then that's done, and then the code continues on from here, okay? That's the real basic nature of a block and being able, what's going on sort of with those other things that we saw is that they're written so that they can take a block. Now, you did see that the other examples had this really neat thing about taking arguments and stuff, and we're going to get there in a bit. But let's go ahead and show you another example. So you can write a method that takes a block, but it doesn't have to take only a block. It can take other arguments to it, other parameters, as well as a block. So we could write a method like this. We could write def repeat. and we'll say num times. So we're going to write some code here where we're going to repeat some code a certain number of times. So we'll say I is equal to 0. And we're going to stick to old familiar while loop. I is less than num times. Now let's call our block. Block.call. Then we'll do I is equal to I plus 1. We'll do an end and an end. Now, you might be able to tell this already, but basically we wrote a method here that we can pass in how many times we want to call the block. So how many times do we want to do the block? So if we write next, if we call, and we can do repeat 5, do puts, let's say the letter A, and then end. All right. So this defines that method. Then we hit this and we call repeat 5. Now, one of the things to note is that repeat only takes one argument. Okay? It's not 5 comma some block, as I would have thought it would be, but it's not. This is one of those Ruby things where this thing here is just special syntax to say this method takes a block. A block is given to it. This is really the length, this is the extent of the true sort of parameters of a normal method. So repeat takes 5 and then a block, but it's when you write it, it has to be written outside of it. I just got to tell you, I find it a little confusing, but this is the way it works. And I think it works this way because they like the way it looks. And because they don't really have lambda expressions. They don't really have anonymous functions. So in R, we really do pass in a function to a method. Here, it's sort of syntax to make it possible for us to do this thing and get it passed in and stuff. Nevertheless, so when we do call this, though, it's really nice. And, as you would expect, we go look at its output. What happens here is we take the 5. And so if you want to, you could say you've got num times, and a 5 goes in it. We come into here and we make I, and I is at 0. While 0 is less than 5, call the block. Well, this is the block that's gone to there. So this code runs and we output the letter A. Then I is equal to I plus 1 becomes 1. We go back, we check, it's less, it's call. So this continues on, 2 all the way up till it's 5. But we get 5 A's written out. Okay, and then we continue on with our code, our program. And again, you could write this as well, if you wanted to, as repeat 5. Do your curly braces, put A, and the curly braces. And again, the curly braces are just another way to create a block that is being given to a method when that method is called, and then the block can be called by that method. Okay. Now, this whole ampersand block thing is considered passé. It's old style, and it's not the way that people really like to write stuff in Ruby anymore because it's too clear. We would like some more mystery. This is unfortunately a recurring theme in Ruby. It's like they want it to look really beautiful, but as they make it more beautiful, it becomes more obscure and more difficult to understand. So nevertheless, it's very unlikely to see code written ampersand with these blocks, okay? and to have a block.call. Instead, what people do is as follows. They go and they do def. Let's do the same example, repeat, and they pass in num times. And actually, they could argue that this is better than what they had before, because what they had before was a little strange where we had the block, but we didn't really pass it in. And so maybe this is a big improvement. I guess obviously I'm on the fence here. What the change is this word yield. All right. So when we have yield, this is the same as adding ampersand block to parameters. All right. So instead of writing comma and block and then a block.call, all we do is we write yield. And then it's understood that yes, repeat is to be used in a fashion as we did before, where we can do something along the lines of repeat, we pass in something, we do our block, puts, this is cool, all right. So puts. Anyways, so you can use it the same way. So this code is equivalent to what was on the previous page. Just call yield. And yield in and of itself says, yeah, I know that this method has got a block coming in. Now call it. So this is like block.call. All right. You with me? Hope so. All right. Now, that's all neat. But you'll notice only thing that we're doing with those blocks is executing them. We're not passing any parameters to those blocks like we did in R. In R, we passed in parameters into these functions, these anonymous functions. So far, the only thing I've shown you with the blocks is it's kind of like a void. It's do this code and let's not worry about it then. We're not going to pass anything into it, and we're not going to pay attention to its return value. Although it has been returning a value, we've been ignoring it. All right, so where do we go with this? Where's this whole anonymous function? So I want to show you an example here. So let's go back to R. So in R, all right, there's a neat method called sapply. Okay, and sapply is a simplified version of lapply. So this is a simplified version of lapply. And lapply's big thing is it takes in a list, it operates on it, and it returns a new list. And so what does it really mean? Let me write out the definition of lapply, just so that we have it. Lapply, and it should be all one word, returns. This is copied from the manual, a list, and it's notion, it's a list, it's not a vector. The same length as x, each element, so x is going to be passed to lapply, each element of which is the result of applying fun, we're going to get back to that, the function, to the corresponding element of X. That's the end of the quote. And so, for example, we can do, since S-apply is a simplified version that instead of giving back to us a list, that gives us back a vector. And so this is really handy because working with lists is actually kind of a pain in our vectors. We're so used to them. They're really nice. You know, vectors are just like an array. So S-apply basically says, I don't want really the list, please. Just simplify it down to a vector for me because that's really what I want. And so you can do, so the idea is you do S-apply X and you pass in a function. And the idea is, so let's say X is some vector. The idea is to apply function to each element of X and produce a new vector and return it. So for example, we can do the following in R. And again, why am I talking about R? It's because I think the transference and seeing things in two-way helps us to learn them. So let's say I make a function in R called double. And so that's easy. Let's just go function X 2 times X. All right, so if I was to call, you know, double of 2, I'll get back 4. Kind of nice. All right. So let's say if I call S-apply and I pass in a vector 1, 2, 3, and I go ahead and pass in as my function double. All right, so this is what X is vector 1, 2, and 3. I'm going to pass in this function that we created here that's in this variable double. I'm going to pass it in there. All right, and then S-apply's job is to apply double to 1, which will become 2, to apply it to 2, which will become 4, and apply it to 3, which will become 6, and return me back a vector then, which is 2, 4, and 6. And so this does, when this gets called, this returns as a value 2, 4, 6. And a nice vector in R. And that's pretty cool. Take in a vector, take in a function, apply it to everything on it, and you're going to get back out a new vector that's been transformed based upon whatever that function is for every single element of it. And so there's all sorts of ways to use this. I mean, it's not just to double things. It's whatever function you wanted to apply. And of course, you could have in here, it's like a vector of vectors, and then you could be computing something on each one of those, some complex thing, even something like median or average or mean, you know, all sorts of great things. Now, we can also take in parameters. So this is important because double here is taking in a value and then it's getting applied, and so that's cool. We can, let me show you, we can do this in R as well. I'm not sorry, we can do it in Ruby as well, not R. All right, so, okay. So let's just state this now. Our blocks in Ruby can also take arguments. Okay, so we could have a block and it takes in an argument y, and it's 2 times y. And all of a sudden you go, oh, I remember from that example at the beginning of all of this, he had that vertical line, a variable name and a vertical line. So this is an argument or a parameter to the block, and I use it in here. So this is just like the double that we just saw defined in R. Okay, We can also write it as do this 2 times y end. So when we want to use the do in the end, we just go ahead and stick that there, and then we put our code in there, and there we are. So nice and good. All right. Now, so let's just go ahead and craft ourselves a sapply in Ruby, because we can do it. We have the technology. We have the power. All right. So we do def sapply. We'll pass in x, which will be our vector. Now let's go ahead, and we're going to be prepared to make a new result. So we'll start with an empty array. We're going to have a loop. So while I is less than so let's not start at 1. That's a bug. Start at 0. While I is less than x dot length result. Now arrays in Ruby have a lot of methods actually already defined on them, just like vectors or array lists and other things in Java and so forth. So we can push onto it like it's a stack, which means just to append to the end of the array. So we're going to push onto it, yield. So we're going to call a block that's being passed into sapply. And what we're going to pass to the block is x of I. Okay. And then we'll go I is equal to I plus 1. End. And then when we're done with the loop, we are going to return our result and end our method. Okay, so let's see this in action. So I could go ahead and I could say, sometimes I like to have variable names with people's names. So Fred is equal to sapply. I'm going to pass in an array of 1, 2, 3. And then I'm going to make a block that takes an argument, y, and it does 2 times y. And because it's the last thing done in the block, that's also the value that the block returns. So this is just like an R. Take in a parameter, compute, it's the last thing done, so that's what we return as the value of the block when the block runs. It's just like it's an anonymous little function sitting here. And we're going to take this anonymous function and pass it to sapply, where sapply has as its argument x, this array 1, 2, 3. And so if you wanted to look at this, you make x, and it goes to some nice array, 1, 2, 3, with indexes 0, 1, 2. We come into here, we make a new result, which goes to, it's currently an empty array, 0 length. I don't know how to draw that. It's something. All right. And then we have I, I is 0. Come into here, it's less than x that length. The length of this is 3. So now we're going to push into result, yield x of 0. Well, all right, x of 0 is 1. So 1 goes into y. 2 times 1, because y is 1, that's 2. That's the last thing computed in the block. And so we return the value 2. 2 is pushed on to result. And now our result has a single element in it, the length 1. That's what result is. I gets incremented by 1. We do back to the loop check, it's still less. So then we take the 2 in here, this goes 2, so 2 times 2 is 4. 4 is the value that yield is returning. 4 is then pushed on to result. I is equal to I plus 1, this becomes 2. While I is less than 3, it's less than it, so now we're at 3, we pass 3 to yield, so y is 3, 2 times 3 is 6. It's the value that's returned by yield, so 6 is pushed on to result. And then we've got that. I is equal to I plus 1, that becomes 3. We exit the loop, we return result. And so our good old Fred here, we wanted to draw it, Fred then happens to be set equal to that array, that object that had been returned by sapply. And if we wanted to, we could go ahead and do P Fred. Now P is handy because instead of puts will take the array and will output 1, then 2, then 3, each on a separate line, which is not really what I want. I actually want to see kind of what it would look like. I want to see it look like an array. And so if I want to see a data type kind of printed like a data type, I can just use P. And so this then outputs very nicely 2, 4, 6 with these nice square brackets. So you can run this code and you could step through it with Bybug, and you should be able to see what's going on. I actually haven't tried that with Bybug yet, but that would be kind of neat to see what happens when I call yield. Do I actually end up down in this block? Probably should. All right. Pretty neat. Now, the thing is, that's blocks. And we can see that a block can return a value, can take a parameter. It acts really like those anonymous functions in R, except we can't put them in a variable and pass them around. We can only have them as sort of a single argument to a method where we can call yield. We can't have more than one anonymous function come into it, not like we did with the G of F in the R example. So Ruby is limited in this regard. It does not actually create first-class functions where they can be passed around as variables and manipulated, but it does give a limited use of them like that, where it can be a single argument to that. Now, should you use sapply in R? I mean, in Ruby, the answer is no. In R, you should, but in Ruby, you should not. Why? Because you should use what's already in the language. So I've shown you this so you can see how this sort of thing works, and that maybe someday you might want to write something of your own that's not already in Ruby. But the reality is that Ruby has a ton of stuff in it. So for example, we could do Beth is equal to 1 to the array 1, 2, 3. Now I'm going to take Greg, set Greg to Beth.map y 2 times y. What does this do? This is map. Map is, you're going to see this in, if you ever use Lisp or Scheme, those sorts of functional languages, and then a lot of other functional languages, you will see map used in lots of places, and it behaves just like sapply does, where the idea is take this thing and for every element of it, apply the function here and build up a new result such that each element has been mapped using this function to a new value. Okay? And so, if we were to P Greg, what we would get out as output it would be very nicely, we would get output square brackets 2 comma 4 comma 6. Okay, so again, what's happening here is we're going to take the 1, put it into the y. 2 times 1 is 2. And so we build up a new output, a new result of 2, 4, 6. That gets returned. We put it into Greg, and we can see that. Beth does not change at all. Beth stays 1, 2, 3. Okay, so this is just a way to transform Beth into something new and get that new thing returned to us, and then we can do something with it. There are actually lots of these sort of methods in R, in Ruby, in R too, but in Ruby. And so there's some cool ones, like you could select elements from a list, and based upon you returning true or false, so you could compute something that, like, say you wanted to do something like, I want all the elements less than 0. Well, it would go through all of these guys, pass you in one at a time. You would check, is it less than 0? And if so, you would return true. And then it would add that to the thing that it's collecting as its output, but not the ones that are 0 or greater than 0. Those would not be included. And then you can get a subset that way. So there's all sorts of cool things in Ruby that work this way. This is how they're working. And that's what I wanted you to know. And with that, I conclude this lecture. All right.